So this is the second part of my advanced games programming coursework, and the current demo includes height map generation, cube maps, light volumes, deferred rendering, and dynamic lights. Now, unfortunately, I am using Fraps to record this, and for some reason it will not display the HUD, but I will say on the right hand side you'll see a list of things that are in the demo, and on the top left you'll see a randomized lights button. The randomized lights just randomizes the color of the lights just to show that the lights themselves are dynamic, as promised. So as you can see, we have deferred rendering and a multiple 49 lights being rendered at 100 frames per second to prove that it is actually deferred rendering. And here we have a height map that is generated from a texture, and the directional light maps to the moon being seen, so it gives off a realistic lighting effect. As you will see, the lighting is calculated properly using per vertex lighting calculations, and it is done by averaging the normal across multiple surfaces for the height map. You'll also note how I also have collision for the height map with the camera, as because all the calculations for the height of the height map is done on the CPU side, not the GPU side, I can use it for collision detection when it comes to the camera. You will also, and as you can see, obviously it's very smooth, it works perfectly fine, and it just looks and feels like you're just walking up and down the hills. So back to the demo, you can see you have 49 point lights spread evenly out, all different colours, and they have around about the same intensity. And this is only possible with deferred rendering, where I ensure that lighting calculation is calculated last through a second pass. As you can see as well, you'll also notice how the lights also do not only affect the terrain, but also affect the house. For performance reasons, I also culled them multiple of the objects. So as you'll see in a second, the house is culled, and that is the same for the height map as well. I just cull back faces. And as you can see, point lights are rendered with a light volume, which means fragment operations only occur on that specific part. It's more efficient. And as you can see, I use a cube map for the skybox, which allows me to render a large skybox a lot more efficiently than I otherwise would. And that's part 2 of AGP. A final note, I'd just like to say this was done individually, not in a team, so I did all the work, and specifically when it came to problems, I didn't have a lot of problems that actually stopped me from doing the application. However, there were a lot of optimizations I had to do along the way, which I have specified in the overview document, which was also part of the assessment. Thanks for watching.